Video number 124, graphing a hyperbola. Let's take a look at the general form for this. We have x squared over a squared minus y squared over b squared equals 1. And this is very, very similar to an ellipse. If you go back and look at ellipse, the difference is plus sign. In fact, let's go through this. There we go. Let's go through this. If you have x squared over a squared, okay, plus y squared over b squared. Let's discuss this. What the situation we came to is that we end up getting an elliptical situation, of course, as long as a and b are not the same. Of course, if a and b were the same, that would make the object circular. Now, what you have here is a minus sign. And minus signs, we all know, invert or reverse situations. So what happens is, because of this one minus sign, what it does is, all right, let's put it in a different colored marker here. All right, what you'll have here is x squared over a squared, so minus y squared over b squared. What you have is this. Instead of an ellipse, you'll take this part here and reverse it this way. This part here will reverse the other way. So the ellipse gets inverted, and it's referred to as what's called a hyperbola. And hyperbola basically means, for lack of a better definition, it means double parabola, right? Hyperbola, double parabola. That's what it means. So you have two parabola for hyperbola. Now, the official definition is just like an ellipse, except it says it's the set of points, all right, whose difference, all right, difference of the distances between two fixed points is constant. So the key word here is difference, which is why you get the subtraction. If you rewind, or if you go back to, I think it's video 117 or whichever one it is, on the first one that we do on ellipses. In fact, I can look it up real quick. But actually, yeah, I'll let you guys do click on the index page. You can go back and take a look at ellipses, and you'll see that basically the definition is the same, except it says sum. All right, let's go ahead and just roll right through this here. So minus sign. What you do here, the center, quote unquote, is 0, 0. What you end up having here is this. The center is 0, 0. What you're going to do is you're going to make asymptotes. We're going to go to the right and left 4. There's a 4. There's a negative 4. There's a 7 for the height and a negative 7. So we end up with this taller asymptote box. Here, that's going to create these guys right here. Okay? Then, here's the deal. Because the x squared is mentioned first, the x values are arguably, quote unquote, larger than the y values, so they're more powerful. So this is a what's called a horizontal parabola. I'm sorry, horizontal hyperbola, because the x squared is mentioned first. Okay. Now the c value is calculated a little bit differently. It's actually a plus instead. Here's why. Here's the c value. Guess where it is? It's outside of the distance that a is. In other words, what? C is greater than a. So that's why you're going to add a squared and b squared together. You get root 65 because you just simply add 16 and 49, which is about 8.1. So basically, for the ellipse, and this is a little bit of a summary video, for the ellipse, c squared would equal a squared minus b squared, or b squared minus a squared. And then for a hyperbola, it would be b squared plus a squared. Okay? So that's pretty much all we need here. And then here's, of course, one where the hyperbola is translated away from the origin. Where's the quote-unquote center? I'm putting it as quote-unquote because we're not really in the center of any particular object as a traditional center, although it is really a center because it's the center of those points. So the center is not 0, 0. It's going to be where? 3, negative 7. So to the right, 3, down 7. Whew, right here. All right? This gives us a B value of 12. This gives us an A value of 6. So we're going to go up and down 12. That's going to take us down to a 19, a negative 19. We're going to go up 12. That's going to take us up to a positive 5. Okay. We're going to go to the right and left 6. That's going to take us out to a 9 and over to a negative 3. So we're going to be here and here. So this would be the asymptote box, or whatever this is called. Now, if we did have a plus sign, the ellipse, yeah, would be right in the middle here. But again, it got inverted. It either got inverted east-west or it got inverted north-south. Well, how do we know? Because the y is mentioned first. So it's definitely, here's the asymptotes. This is definitely the shape of the graph. Now, one thing I was wondering, and maybe I should address this in another video, but I actually don't know the answer to this question, but I want to ask it anyway. I wonder if the same pattern fits for hyperbolas that do for parabolas. And chances are it probably does. See, our C value is definitely 13.4. So if we went up 13.4, that would take us up to about 6.4 for the height. I'm wondering if this distance here, which would be about 1.4, if you multiplied that by 2, I wonder if that would take us this way, just like it would for a parabola. Now, you don't have to worry about this for these problems in this, and usually in your pre-calc classes, but it's just something to consider. I wonder if it's 1.4 and then 3.8, or I'm sorry, 2.8, 1.4, 2.8. So, anyway, nonetheless, good times. By the way, domain and range. What would be the domain for this? Right? Well, you can plug in anything for x, doesn't matter, so you call it all real numbers. Range, well, the range starts at negative infinity, works its way up to, what is that? Negative 19. Put a hard bracket. Union, start at, where is this? 5 to infinity with a soft bracket. So, anyway, good times, good luck. Talk to you later.